Hello, let's discuss the IUPAC rules for naming organic compounds. So here we have the Greek prefixes to some extent, except we should note that the first four are different. So take a note that meth is 1, meth is 2, and so forth. I just like to think of it as MEP, if I just say it out loud. It's like MEP. And then the rest follows the traditional Greek prefixes. From 5 and onward. So I'm assuming 13 would be tridecane, if I'm not mistaken. Just for example. Let's confirm that. Right. Tridecane. Yes, indeed it is. Let's see. Okay. One thing that would be useful to take in consideration are the iso, sec, tert, and isobutyl. Well, technically just iso. Let's see. Whenever you see iso, you know there's going to be some sort of Y shape. So let's see, counting the carbons here. Okay, so 1, 2, okay, let's see, actually, this is going to be isobutyl because there's 4 carbons. It's isobutyl. Okay. And isopropyl. Let's see. Okay, so isopropyl. This is actually where it is. This could be something else. Probably another carbon chain, I'm assuming. But we will look into that in an example. Just write that there. It's 1, 2, 3. Isopropyl. And let's also talk about why something is called sec and tert. I'm not quite sure why something is called iso, but if you know, please feel free to share. That would be great. But for sec and tert, that is actually something pretty obvious. Let's see. So it's connected at this point. This is considered to be a secondary carbon because this carbon is attached to 2 other carbons as opposed to this one, which this is a tertiary carbon because it's attached to 3 other carbons. So secondary, this is tertiary. Let's see. Let me count the carbons here just to make sure I didn't put too many. 1, 2, 3, 4. Okay, so this is technically something else there. Let's see. Okay, I'll just let you count those just to clean up the wording. This is sick. Butyl. Let me put this in a different color. Probably orange. And this one is tart butyl. Okay, so as always, let's see, identify the longest carbon chain. This will be important, especially later on, which we'll get to. Let's see, longest carbon chain, parent chain. So identify the parent chain. Let's try that. Parent chain. So when identify the parent chain, the longest carbon chain, identify all the substituents. Okay, groups appending. We will talk about the substituents in a moment as well. Let me just check this. Perhaps I'll just write it in. Okay. We need to talk about the substituents. Let's see, more than once. Okay, there's usually a very long list, so priority groups, get it. Okay. I do have an acronym that we can use that I've made up. And those substituents, I'll probably call them priority groups. That's what I've been familiar with. This one has this order, but I like a different order. Let's see, let me check. This one is the one I used. Priority groups, okay. So I have something that looks kind of weird for these substituents. Basically, carbs eat acids. I know that's just strange, but Amy needs all the kittens alcohol turns my brain to be alkene, brain and alkene, alkyne. Okay. Amine. This is technically amine, but it just looks like it. It's a steel. Fail. This is alcohol. All the kittens. Okay, I need to reorganize this. Aldehyde, ketones, ketones. This is nitrile. This is amide. This is carboxylic acid. Carboxylic acid. This is ester. This is acid chloride. Okay. Then you want to take into consideration of the way it's organized. So this is basically, let me put this in another color. Let me pick a different color for this. Let's see. Go back to blue. Okay, like an owl, carboxyl acid, okay. An ester. What else is there? An ester will basically be very similar, but this will be an R group. Hopefully if I put R here, that makes sense. R means alkyl group. And an alkyl group is basically a carbon group. Let me put this in a different color. No, that's not going to show very well. No, not that one either. Okay. Let's see. Yellow will work because of the background. Alkyl group. Yeah. An alkyl group is basically saying a carbon group of something. It's a generic name, if I'm not mistaken. This is basically saying or. Here we can put a prime symbol to indicate that it's something else. Basically, there's an alkyl group on that single bonded oxygen. Acid chloride. Ester O8. Okay. So the suffix is usually something with the highest priority. This would be like oic acid. Highest priority, that will make sense later, hopefully. In the second prefix, to distinguish it from prefix. Usually prefix is just for the substituents, and it goes in between the name, and of course, or you can think of it as like before the name, but it looks like in between the name. I've never seen this one being used. So I have to look into this some more. Box C, okay. This one would be CO. Okay, so this one's basically gonna look like this. This isn't, well, it has chloride, but there will be a different list which we'll look at. CO. Okay, that looks weird. Let me put that there. Okay. This would be oil halide. Strangely. Oil halide. Oil halide. Prefix. Halocarbonyl. Okay. Halocarbonyl. Okay. And also carbonyl. This is a carbonyl. It's probably connected to something else. So, but this part, this is a carbonyl. And you can also simply Google that. There should be a resource that you can use. Carbonyl. Let's just find that. It's probably this one that works. The C carbon double bonded to O entity itself. It's a carbonyl group. Okay, that works. Okay. If, let's say we have, let me just make some space here. If this was like that, this would be a ketone. It's a ketone. And also, which we'll get to in just a second, there's also that aldehyde. And remember, aldehyde has higher priority than ketone. Amy needs all the kittens, aldehyde, and ketones. Let me put, I wonder if this will let me, no, okay. Okay, well, I'll just put it here. Basically, aldehyde, this hydrogen right here, aldehyde, hide as in this part probably refers to this hydrogen. So yes, Amy needs all the kittens. Amy. Okay, so this is gonna look like. Technically, there are different amides. Okay, let's see. So let's just put, in this case, there's like a methyl group. Let's make this smaller. It doesn't have to be this. Let's just put R's there to represent some sort of alkyl group. This R there, that's an amide. This would be it's like a tertiary nitrogen there. But actually, I think this classification belongs to the amines with an AMINE, whereas this is AMIDE. Just to clarify. Nitrile seed, never really seen carbonyl. Carboxamide, carboxamide, amide. Let's just put this in a form like that real quick. Oh, I need to put a C there. C here. A C here. C here. Okay. RCO and R okay, let's just put this here. 2 R groups. Unless you want to copy that form, I guess, in the website, that's fine. So, okay, I've never really seen this before. Carbonyls, but let's look at the suffix first. Carboxamide or amide. Let's just put amide. I'm pretty sure amide is more popular for the suffix, and then the prefix. I've never seen this one before, but we'll just put it here. Carbonyl. If I'm pronouncing that correctly. Nitrile. Okay. So nitrile. It's basically this. Carbon triple bonded to N nitrogen. Okay. I'm not sure how to put that into the R. This would be like RCN, probably. But then you just need to note that it's. I'm not sure if that's something that's written. Let me check. RCN. Nitrile. One, two, three, four, five. Yeah, RCN seems to work here. Let me put this here. DS, and then the suffix. Okay, so I'll just put nitrile, that's a suffix. Then cyano, I've never seen that. How strange. Cyano means blue, is it not? Cyan. Okay, aldehyde. Aldehyde. Okay, let's try this. Well, I've already covered this before, but just say it again. It's basically RCOH, I guess you could say. RCOH. Suffix is going to be AL. Mentions carbaldehyde, but I've mainly seen the AL suffix. Formyl. Okay. Have to look into that. Because that reminds me of formaldehyde, which we tend to hear about a lot. Formaldehyde. If I'm not mistaken. So that's one. Formaldehyde is one carbon. It's a one carbon aldehyde. acetaldehyde. That's 2 carbons. So here's 2. There's probably a chart out there. Let's see. The high chart. Let's take a look. So there's methanol, ethanol, propanol. Propanaldehyde is the IUPAC name versus the common name or the stock name in this case. Ketones, okay. Okay, let's look into this. Ketone, voila. Okay, RCO. Let's just put that there. If I'm not mistaken, that's what it is. Just looks kind of funny putting it in that form. Alright, it's gonna be oxo. Acetone is the most simple form for a ketone, if I'm not mistaken. Is it? Acetone structure. Yes. The most simple form for a ketone is an acetone, 3 carbons at the minimum. Because there's 2 other alkyl groups. So an alcohol. An alcohol is a hydroxy. Okay, they just basically have, let's just say it's OH. It's really that simple. If you really want it, then okay, we can put that ROH. It helps me to some extent. Let's see. This one, well, it's just OL. OL. Okay. And this one would be hydroxy. Prefix. Oops. Okay. They all basically the SH. Replace oxygen with sulfur. Okay. And this one would be, okay, here's Theo. I wonder why. Mercapto. Nope. Okay, Mercapto. So the amine, basically, the amine is just, this is weird, but basically it's just single bonded, some sort of, let's just put R here, except for carbonyl. Otherwise, that would be the amide. So just some regular old just single bond carbon, some sort of chain of some sort. This one looks like mine. That's why I associate it with my. That's what helps me to remember it. And then amide, I think of it as Amy. Amy needs all the kittens. Ta-da. Okay, maybe I'll get into the property of the ring for the nitrogen part. But in this case, they have it as, well, it could be hydrogens. In this case, this would be like a primary, because there's one other R group or one other carbon. Or you could have something like this. That would be secondary in theory. This is just a theoretical form, of course. I can give you an example in a moment, possibly. But it shouldn't be too difficult to visualize. This would be tertiary for sure. So let me just circle this so you know. That way you know which one to look for. Okay. Okay. What else was there? Deals. Okay, suffix. Of course. And then prefix amino. What that would mean. I associated brain with alkene. Just because they kind of sound similar. Brain, alkene, kind of. Well, I mean, it's just double bonded carbons that we're talking about. Something of that sort. Let's put R there. That helps. Oh, I've never seen this. Alkenyl. Pretty sure this what's important. Okay. That's funny. Doesn't really have a dash at the end as well. Never seen that before. Let me just put this in here. For alkyne. Alkenyl. 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 Basically carbonyl triple bond, carbon triple bond of some sort. Okay, and then the rest I just have it as aeons if I remember correctly, AE. AE on. This was the acronym, or just the. That's an H there. That's how I remember this chart. Just alkane, basically. This is going to be ether. Ester, remember, requires that carbonyl group. Ether would just be like an oxygen, just some oxygen, well, like sandwiched between two alkyl groups. And then this is basically alkyl halide, not an acid halide, but alkyl. So alkyl meaning just some carbon group, except for the carbonyl group, which forms the carboxylic group, but also other things too. If it has a carbonyl group, then it's going to be called something else. In this case, because it's a halide, it would be like acid halide if it had a carboxyl form or carbonyl form. So this is alkyl. It makes more sense if we just draw it out. Alkyl halide. It's just nitro. Nitro, okay. Alkane, basically carbon, single bonded. This is basically R, just single bond, sandwiched between two others. Carbon. Let me put this, just put it like this. Make sure to clarify not carbonyl. If that was carbonyl, then this would be sort of like an aldehyde of some sort, or an ester. If this R were here, if you think back, so imagine this first R was carbonyl, and that would look like something else, like, let's say, I'll just leave that to visualize. This second R, if it was hydrogen, then this carbonyl, that would be like aldehyde, and carbonyl plus another carbon group would be an ester. So something to just be careful of. They just give us this example. Just make a new list. Doesn't look like ether has. Okay, let's see. Ane. So all of those have ane. These all end in ane. That's what this is saying. Okay. Alkyl halide, basically RX. That's basically what it is. And nitro. Interesting. This has a formal charge. Negative here. 1, 2, 3, 4. This nitrogen has a positive charge here. This would be a resonance structure, if I'm not mistaken. Nitro. All of these are A. The prefix probably differs, yes. Halo or Brahmo. I'll just put it right here. Halo. But so they use bromomethane, which is basically CH3Br. Okay, nitromethane would be this nitrogen. This would be this R group would be methyl group. Nitro. Okay. Okay, so that's the substituents, but this is just one source. There's actually another source. And this one puts acid and hydrides, whereas the other source did not list acid and hydrides. I don't have a mnemonic, but I just remember in general that there's carboxylic acids and then there's esters. This one just sandwiches acid and hydrides in between. Acid and hydrides would be this. Looks like, it sort of looks like, I guess you could call it like an ester, but basically there's two carbonyl groups here. It's two. So it's kind of like those ethers that we talked about. There's an ROR, but this is specifically two carbonyls. So R carbonyl, O carbonyl, R. Which is bizarre. Basically just two carbonyls. This is an acyl halides. Instead of the acid chloride, it's just acyl halides. And then my acronym still holds to some extent. Carbs, if we skip acid and hydrides, carb eats acids or acyls. This also has acids in here, but oh well. That's alright. Well, Amy needs all the kittens. Yep. Alcohol turns my brain. Okay, this one, it skips the order around a little bit, or adds in, change the order a little bit. Alcohol turns my ether. Sulfides. Oh wow. I've never seen those. Sulfides? Okay. Alkenes, alkynes, alkyl halide, nitrile, and alkanes. I guess alkanes just goes to the lowest. This is one possible. I guess once you get past amines, the order is pretty arbitrary. Past amines, well, everything it basically has an alkane suffix, like we mentioned. So you just have to name the substituents below amines here. The prefix matters more, I'm assuming. Okay, let's actually get back to the IUPAC. So 3, finally. So that was the long part. The number of the carbons of the parent chain from the end that gives the substituents the lowest numbers when comparing a series of numbers. So basically, if there's another way to name a compound between two, pick the one that has the substituents with lower numbers. So I'm just gonna word it like this. Maybe we'll just use I'll try my best to make the skeleton. Okay, let's just put CH3. Let's see, 1, 2, 3, 4, 5. Okay, let's make this exaggerated. CL. So just pretending this is, if we pretended to number it like this, and then numbering it the other way. 1, 2, 3. That doesn't look right. 3, 4, 5, 6, 7. Okay, so the orange one looks shorter, so this would probably be 2-methyl-4-chloro. Actually, if we alphabetize it, then this would be 4-chloro-2-methyl. That's also something that needs to be taken into consideration of the numbers. Let's look into that. Let me see if this exists. So 4-chloro-2-methyl heptane. 4-chloro-2-methyl heptane. So indeed this exists. So 1, 2, 3, 4, 5, 6, 7. Indeed, yes. So 4-chloro. It's good to check your work sometimes just to confirm. 4-chloro-2-methyl heptane. Here we want to put the chloro first because that comes earlier. The C comes earlier in alphabet compared to the M and the methyl. There are other examples, of course, where sometimes if you can get the numbers and the letters in the right order, then also try to go for that. You just need to experiment, test. I say experiment, but just name all the possibilities and pick this one compared to wording it the other way. If you want me to word it, I can say it out loud at least. The incorrect way would be like, let's say, there's just so many incorrect ways. I'd rather focus on the correct way. No. Okay, alright. Let's say chains of equal length are competing for selection. Yes, that brings us to that point, number 6. The chain which has a greater number. Oh, wait. Oh, okay. Never mind. But this is just equal length. Greater number of side chains. Okay. Greater number of side chains and chain whose substituents have the lowest numbers. Yes, we've mentioned that. The chain having the greatest number of carbon atoms. The smaller side chain. Okay. The chain having the least branched side chains. Oh. Okay. Okay. I need to see that. There are two or more different substituents listed. They are two or more different substituents. They are listed in alphabetical order. Yes, that's fine. Using the base name. Ignore the prefixes. So if there was like two methyls here, ignore the di. Just use the methyl. So let's use that as an example. Well, I guess we could put it here. For example, let's put this in blue. So now this becomes, it's still going to be 4-chloro. This is going to be 2,3-dimethyl heptane, if I'm not mistaken, which we'll look into. Chloro, 2,3-dimethyl heptane. Interesting, they don't have an example. Is that because it looks like something else? No. Not sure why they don't have it here. Guess it's just not shown. It's just not something that someone has inputted. So it's like 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3. Oh, 2, 3, oh, okay, 1, 2, 3, 4, 5. Indeed, it exists. Alright. And check your work with that method as well. Which is maybe I'll put this in chemistry. Okay. Cyclic green, cyclo, okay. 4-chlorobromoiodide, as mentioned. Let's kind of go over the similar things that we talked about. So I guess we just had to look for practice problems here. Hopefully it's letting you see this. Okay. This is also, this looks important. Okay, well, I think I'll just end this video at this point. Thank you for watching, and feel free to leave any comments. I'm open to hearing from other people about the thoughts that they had for this video, or any suggestions for improvements in terms of video making, and I hope this helped to some extent.